Now consider a body moving along a circular path. And it is covering equal distances in equal interval of time, means its speed is remaining constant. But as it changes, as it moves, it changes its direction. So when you talk in terms of velocity, velocity being a vector quantity, even though the magnitude equal displacement is happening in equal interval of time, even the magnitude is same, but since the direction is changing, so velocity is changing. So speed is constant because it covers equal distance in equal interval of time. The magnitude is same always, but when you talk in terms of velocity, velocity depends upon magnitude and direction. So magnitude, even though magnitude is remaining same, the direction is changing, so velocity is changing. And if the velocity is changing with respect to time, you can say acceleration is there. And acceleration can happen only if an external force acts over it, as per Newton's law. F external is equal to m times a. So if an external force must be acting to produce this acceleration. Now, what is that speciality of that external force? That external force is not changing the rate of displacement or how much distance is covered. It only changes the direction. Now, how can you find the direction of that external force? If the force was acting in the direction of the motion of the body, obviously it may have led to the increase in speed, because the rate of change of the distance covered increases because the force is pushing it to have more and more displacement. So obviously the speed remaining constant means the distance covered is same with respect to time. Now that force should only do a change in the direction. So that force should not be acting along the direction of the displacement of the body or the movement of the body. Neither a component of the force should be along the direction of motion. So the force can act only along the radius of that body, which leads to the change in the direction. And that force which is acting along the radius of a body which is taking a circular path is what you mean by the centripetal force, which actually changes the direction but does not make a change in the magnitude of the distance covered or displacement. Now centripetal force is given by the formula mv squared by r. Now there is another force called centrifugal force, which you call as the centripetal force and centrifugal force. Centrifugal force, which is considered to be a pseudo force, means which is not actually present, but we have to assume that such a force is there because forces always act in pairs. So if centripetal force is making the body to move in a circular path and it is acting to inverse, then an equal force should be acting on the body in the opposite direction of the centripetal force, which you call as the centrifugal force. Acting in the outward direction. Since the body is not moving neither towards the central point or towards the radius or away from the radial path, both magnitude should be same. Centripetal force magnitude and the centrifugal force magnitude should be same. That is why the body is neither moving towards the center or moving away from the center. So the magnitude of centrifugal force is also mv squared by r. Now how to visualize this centripetal and centrifugal force? Assume there is a merry-go-round, or you can say a disc being rotated, and a body is tied to a string, and a person is standing out and watching what is happening. So body is taking a circular path. Why it is taking a circular path? Because a centripetal force is acting along the string. The tension of the string provides the centripetal force. and that's where the body is taking a circular path. The magnitude is mv squared by r. Now when the string is if it is disconnected or if it is broken, then the body will move tangentially away as per the person who is standing outside. Now assume another person is standing on this merry-go-round and he is also watching that body. And he can see the body is being tied to the axis of rotation by a string. So a force is acting on the body so that it does not get detached away, so that already said it is whose magnitude is equal to mv squared by r, and the body is neither moving towards the axis, because see a force is acting over that body and it is pulling it towards the center. So actually the body should move towards the center as per the person who is standing on that disc, but he is not feeling that the body is moving towards the center, even though a force is acting over it. So he should assume an equal force is acting in the opposite direction on that body, which is counterbalanced. That is why this body is not being pulled towards the center, and that opposite force is the centrifugal force. How can he justify that? Once the thread is broken or the string is broken, he feels the body is moving just radially outward, because of whom? The centrifugal force which he assumed. So even though centrifugal force is not a real force, we must assume that such a force is acting whenever a body is experiencing a centripetal force. And a person who is in this particular example, even though the person who is standing outside doesn't feel the presence of centrifugal force, but a person on the body, which on this disc, who is seeing this body being tied to the string, will get his calculation correct only if he assumes a force which is acting in the opposite direction, because the body is being pulled towards the center. The body is not coming towards the center, so some other force will be acting on the body which pulls it outwards, and his argument is justified. When the string is broken, the body moves outwards, so that force is centrifugal force, equally balanced to the force which is pulling it inwards. So its magnitude is also mv squared by r. So these are the two forces acting on a body which is taking a circular motion: the centripetal force, which is a real force, and this is a pseudo force, but its presence is inevitable.